All right. Hi everyone. So today we're going to look into arithmetic operators. In the previous video, we're looking into the assignment operator, and we're pretty much trying to define this operator. And yeah, now we're here, the arithmetic operator, arithmetic operators. So I think we will. I think it's best to continue with the same idea that we did last time. So in defining what these operators are, that's where we can go into it. This, what are arithmetic operators? But now, as I think about this, also, one of the things that I'm learning is that as much as we know we're talking about arithmetic operators, they are applicable in different situations. For example, our arithmetic operators can be unary. What is this term? Let me look for it here. Okay, they can be unary operators. And they can also be binary operators. So far, we do know what we mean by this because we defined what unary operators are and what binary operators are. So, for example, this can be a negative sign, or it can be a subtraction sign. It can be a -1. That's the one thing that it can be. Or, okay, it can be a -1. And we do know if we do this, it's going to display a -1. Or it can be a subtraction between two numbers. As we can see, the answer now yields to 0. So those are the things that we see when we work with arithmetic operators here. So they can be both unary operators and binary operators. That's one of the things that I'm learning about arithmetic operators. Okay. So we're done with arithmetic operators. Swift has 4 standard arithmetic operators for all number types. Okay, so all number types get these 4 standard arithmetic operators. So I want to record them down here. Okay. Okay, so what we understand is that there are 4 standard. Okay, there are 4 standard arithmetic operators. And these are obviously addition, subtraction, multiplication, and division. I hope I spelled division well. Okay, so those are some of the things that we have. And obviously, we're going to follow the bottomless rule as well. But then let's see here. I like arithmetic operators in C and Objective-C. The Swift arithmetic operators don't allow values to overflow by default. I don't understand what this means here. You can opt in. You can opt into value overflow behavior by using Swift's overflow operators such as A and B. See overflow operators. One of the things that okay, advanced operator. I know advanced operators are found in. Overflow operators are found in the advanced operators section. As we can see, we're on advanced operators. So for now, I'm gonna just ignore this until we get to it. The addition operator is also supported for string concatenation. Okay, joining of 2 strings. Those are some of the things that we do see here. Now I don't know if I should go for everything that is here, and I think it'll be sense if we do it that way, rather than just jumping on to one thing. Anyway, because that should be just the introduction of arithmetic operators. Now we do know as well that the remainder operator is also an arithmetic operator. Unary minus, okay, we have a unary minus operator, unary plus operator, compound assignment operators. There's those as well, comparison operators. But then now, once we get to comparison operators, we're no longer on what is this? Arithmetic operators. Okay, let's check here. Now, I wonder if it's possible to see what contains of arithmetic operators, but it's fine. Let us stick to this for now. So, where am I? Oh, I'm in the wrong space. Sorry. Okay, arithmetic operators. Okay, so I think one thing that I think is also valuable is to also talk about remainder operators, since they're also part of arithmetic operator. And I think it makes sense because, as you can see, the heading for arithmetic operators is bigger than remainder operators, which means it's within the arithmetic operator heading. So now, what is remainder operators? Good question. Remainder operator. So what is this operator? The remainder operator, well, the first thing is that it's a binary operator. That's the first thing that we learn. The remainder operator is a binary operator, and as we came to learn about a binary operator, it operates on two targets. That's what we learn here. So in order for us to use the remainder operator, we need two targets or two values, A and B, in order for the remainder operator to be used, right? The remainder operator works out how many multiples of B will fit inside A, and returns the value that's left over, known as the remainder. So that's what I'm supposed to put in. It's a binary operator here. So I think so far this is quite standard, and I think it makes sense. Pretty much it gives us the remainder. That's what I'm learning here. It gives us the known as the remainder. No, the remainder operator is also known as modular operator in other languages. However, its behavior in Swift for negative numbers means that, strictly speaking, it's a remainder rather than a modular operation. Okay. I think I understand what we mean by this. I think last time as I looked into this, one of the things that I came to learn is that the remainder operator will never return a negative number. And let me show you what I mean by that. For example, if we do something like this, minus 3. Okay. How many, what's the, okay, well, it's going to give us 0. Okay, we know 2 is going to go into minus 3 once and then leaves a negative, no, and leave only 1. So the remainder here is 1. But we're getting a negative number. So where did I get not a negative number? The remainder is negative, or maybe I'm looking into it the opposite way. 3, oh, well, okay, 3. Well, we know the answer is going to be 1 and not negative 1. That's quite interesting. So which means it takes this value and it tries to assess what's left off of this value. If this value is already in its negative state, it's going to return the answer in a negative state. It's not going to change it into anything else. So now what is the difference between this and a modulo? Because now we see how many times does negative 2 go into 3? And the answer that we get is 1. So which means, because ultimately we know on the number line, And I think that's what they were trying to show. Okay, on the number line, let's check if there's a scientific calculator here. Because we know -2 goes many times into 3. -2 divide, oh, no, but that doesn't make sense. What you're saying doesn't make sense, Chico. I think you might want to look into your stuff again. Yeah, you might want to look into stuff again. That's not true. I'm wrong. 2 divided by 3. Yeah, well, it makes sense. It shouldn't care about the state of the number. It goes once and then returns. The remainder is 1. Okay, that's what we get there. And we can prove this thing, because if you say -1, we get, oh, sorry. And then we get this, and then multiplied by 2. It leaves us the remainder, which is back to 1. So I was wrong in my initial assumption. But then, why was I so wrong? Anyway, what we're learning here is that if I have -3, and then I try to get the remainder, how many times that 2 go into 3, or what is the remainder? The remainder is -1. And so now if I say 3, okay, 2, the remainder is going to be 1 still. And even if I do the same, but then with a -2, the answer is still going to be -1. So which means it takes, I guess, it takes this number, and if it's a positive number, it returns a positive value. If it's a negative number, it returns a negative value. Those are, I think, what we're learning and seeing here. Here's how the remainder operator works. To calculate 9, the remainder of 4, because ultimately it's a division. I'm trying to think of the best way to say this expression here. And I don't want to say 9 modulo 4. The logic there doesn't make sense. The remainder of 4 in 9. That's what comes to my mind. You first work out how many 9s fit, how many 4s fit inside 9. So that's 1, that's 2, and then the remainder is 1. You can fit 2 4s inside 9, and the remainder is 1, shown in orange. So therefore it equals to 1. To determine the answer for A and B, the operator calculates the following equation and returns remainder as its output. Okay, where some value is larger is the largest number of multiples of B that will fit inside A. Inserting 9 and 4 into this equation yields, okay, yields 9 is equal to 4 times 2 plus 1. That is the remainder there. The same method is applied when calculating the remainder for a negative value of A. I like how there's a nice way of doing this. I mean, this is so cool here. Okay, I like now they're explaining this value to us here. They explain this value to us. And I like also what we're learning here. Now, this is a wonderful method. I think I should make a separate video for remainder operators so that we can discuss them, but I guess we're done as well. So I think it's fine. We'll just leave it here. But then also we're just going to end up going into discrete mathematics trying to find out how to explain this expression, but it's fine since we're not going to be delving deeper into that. Giving a remainder value of 1, the sign of B, the sign of b is ignored for negative values of b. This means that a modulo b and a always gives the same answer. This is what I wanted to say, I think. I guess I was wrong when I say it always returns a negative number, but then rather the sign of b is ignored. That's the thing. That's the thing that I think we wanted to look into, because ultimately we can see this 4 here, but then what if this 4 were to be a negative number? What would happen then? Okay, what would really happen? Because if this 4 was a negative number, how do we justify ignoring the sign of b, which is this 4 here? How do we justify ignoring this? If this 4 was a negative number here, if our expression looks something along these lines, let me check here. Okay, I think I did something. Okay, cool. If our expression looks something along these lines, because, well, I can't do this for now. Well, we do know it returns a negative 9, but then if I do this, it returns a 7. So then if I do this, then what's gonna happen? It still returns a 7. So it appears that the moment this becomes a negative value, wait, how was the expression when I first found it? Okay, this was the expression when I first found it. So what we do see here is that we have 4. It returns a 9, but then as soon as I do this, we're going to have 4 multiplied by 2, which is going to yield a negative number. We're going to have something like negative 8 minus 1, which yields a 9. Which yields a 9. Oh, I guess another thing that I'm learning as well is we want to be careful with the spacing, because as soon as I put a space, this is now taken as a minus and not a negative 8. Interesting. So then, well, the answer should be 7 now. Anyway, I don't know how to explain this mathematically, but it's fine. I don't know why my brain is not there now. Okay, giving a remainder of value -1, the sign of b is ignored for negative values of b. This means that the remainder of b in a and the remainder of negative b in a always gives the same answer. Okay, interesting point. Yeah, well, we came from far. No, an interesting video. I like how doing this has exposed that I was wrong in what I thought about the remainder. And I'm thinking, how could I have gotten it wrong? But either way, it's impressive and I think it's amazing. Okay, that's the end of the video. Thank you guys. Cheers.